G'day and welcome to the next video on sketching quadratic graphs. In this video I'm going to look at what happens when you've got a negative parabola or negative quadratic. What I mean by that is if you've got ax squared plus bx plus c, a is actually less than 0. Okay, so we get a negative outside the front of the x squared here. I still go through my the same things, but it will make a significant difference, which I can show you a little bit later. The y-intercept is when x equals 0, so I still get negative 2. It makes no difference to that one there. My x-intercept's slightly different, or you have to go about it a slightly different way. If y equals 0, that means I can find the x-intercepts negative x squared plus 3x minus 2. At this point, you don't have to, but this is what I would recommend. I would take the negative out as a common factor, okay, or at least take the negative out of each term. So I get negative bracket x squared minus 3x, that's change, plus 2, because that's changed as well. And then I divide both sides by negative 1, and 0 divided by negative 1 is just 0 anyway, so it kind of just kills off, it disappears. And I get x squared minus 3x plus 2. And then I factorize that using the cross method, and I end up getting my answers of x's 2 and 1. So I put those three things on my graph. Now I need to find the turning point. To find the turning point, I use the I added both of them together, so that x-intercepts together, 2 plus 1 divided by 2, so I end up getting x equals 3 over 2. And then I substituted that back up into my original graph, not back up into this graph here, sorry, this formula here, or not into this one, into my original one. You don't have to, but I feel like you make less mistakes if you do that, or at least you identify where your mistakes are. So I substitute 3 on 2 in as x. Notice here the negative is still outside the bracket, because it's not negative x, it's not like this, it's not a negative x squared, it's actually negative x squared. So I've got this one here, not this one up here. So I end up getting negative 9, so 3 squared over 3 over 2 squared is 9 over 4, and then negative plus 9 over 2 minus 2, and I end up getting negative a quarter. So my turning point should be 3 over 2 and negative a quarter. So I go up, and again I put that down, I'll put that up there. Now the difference with this one is that I don't feel like I'm going to be able to do that because of where all the dots are. In fact, this one is going to do the opposite. This one is actually going to do something like this. It should go through that point there. So all of these points should be labelled 3 over 2 and a quarter, and 1, 0, and 2, 0, and 0, negative 2. Now, the key difference that this negative makes is that it turns it from a smile into a frown, which kind of makes sense, because if you're positive, you have a smile. If you're negative, you have a frown. Okay, so if the A is positive, it's a smile. If the A is negative, it's a frown. And that's really what the only significant difference that it makes for us in what we need to understand. Okay, so if the negative is out the front, we largely do it the same way. We largely work out all the values in the same sort of method, or same way. It just alters the final answer. So if A is positive, it's a smile. If A is negative, it's a frown. Okay. That ends the section or the series of sketching quadratic graphs using the intercept method. In the next couple of videos I'll have a look at sketching the quadratic graphs using the turning point method. So thanks very much for watching.